Deep within the walls of the National Aeronautics and Space Administration, behind a 4,000-kilogram vault door, lies one of the keys to understanding our closest celestial neighbor, the Moon. It's been over 50 years since Apollo 11 crashed into the ocean after an 8-day mission to the Moon and back. And in addition to safely bringing 3 brave men back home, NASA brought back souvenirs to commemorate the experience, hoping to get a deeper understanding of the formation of our solar system at large. In today's video, we are going to be talking about the Moon, more specifically, samples from the Moon. Before we begin though, make sure to subscribe to SkyTL and hit the bell icon for notifications. Now, let's get into the video. Scientists at NASA have been studying moon rocks and soil for over half a century, ever since they were brought here. With technology constantly changing and evolving, some samples were placed in special vacuum-sealed containers and closed in a vault. And it wouldn't be until 2019 when NASA would finally open them and see what's next in our investigation of this massive rock that sits beside our planet. So where are these samples, and what have we learned from them in the past 50 years? What could these samples mean for the next 50 years of space exploration? Well, to fully understand this, let's start at the beginning. July of 1969 marks an outstanding achievement in human history. The Apollo-Saturn rocket blasted 3 astronauts through the sky and out of Earth's atmosphere, where it would begin its 3-day journey to land on the Moon. Of course, Neil Armstrong was the first human being to ever set foot on the Moon, famously taking 1 small step for man and 1 giant leap for mankind. Buzz Aldrin followed soon after, and the astronauts set off to explore. Millions of people around the world tuned in to watch live footage of one of the most remarkable moments in the 20th century. Rocks were mined, and samples of the Moon's frozen core were collected for analysis back on Earth. Unfortunately, many original samples have been stolen or lost over the years, but despite this, experts at NASA have still been able to get important data about the contents of the Moon. These 50-year-old samples have been crucial in understanding how the Moon and our entire solar system in general might have formed billions of years ago. The very first sample that was ever brought back from the Moon's surface was labeled 10084, and it crashed into the ocean after the astronauts of Apollo 11. It contained approximately 382 kilograms of moon soil, known as regolith, and to this day, it remains the most studied geological sample in history. One of the main things that astronomers have been looking for in these samples of regolith has been volatile elements such as H2, as finding these elements could potentially reveal if there is or ever was water on the Moon. The samples collected of the Moon's core were vacuum sealed and locked up until 50 years later. One reason why these samples had to wait so long to be investigated was that experts from 1960s NASA understood that the technological abilities of future space experts would likely have much better equipment and techniques to analyze the samples. The most important sampling of the Moon's soil was actually made spontaneously, right before the astronauts were getting ready to head back to Earth. Before leaving the surface of the Moon, Neil Armstrong and Buzz Aldrin thought to scoop up some of the soft dust and dirt on the ground, and this sample would be the largest sampling of Moon debris brought back from Apollo 11's mission. In that sample of dust was a surprisingly familiar mineral that had been seen before on some of Earth's hottest locations. The mineral anorthosite is formed when hot magma begins to cool, and it floats to the surface of the magma, like ice in cold water. This was a very important piece of information, as it had the potential to confirm one of the main hypotheses of how the Moon came to be. The most widely accepted model of how the Moon came to be is the Large Magma Ocean model. This model hypothesizes that at some point in the distant past, the Moon was once covered with molten lava, with various types of rocks and minerals crystallizing as the surface of the Moon cooled and hardened over billions of years. The Moon is also believed to have begun its formation after a Mars-sized object that astronomers refer to as Theia hit Earth. Shooting molten debris into space, it created a belt around our primordial planet, and over time, the debris knocked into each other, eventually creating the moon as we see it today. This theory was actually first proposed by Charles Darwin in the late 1800s, who suggested that the Earth and Moon used to be one celestial object, but it wouldn't be until the 1970s that this theory was brought into the mainstream science world and taken into serious consideration. A big reason why Darwin's theory wasn't popular in its time was that the theory couldn't be tested, because of course there isn't a science lab on Earth big enough to simulate two planets crashing into one another. So Darwin's original hypothesis would have to wait almost 100 years for computerized simulations that could recreate what might have happened all those years ago. Now, no human has gone back to the moon since 1972, so what happened? Why haven't we been back in 50 years? Well, you have to understand that the major motivator for the United States to ever get to the moon was the Cold War. During the 1950s and 60s, the two superpowers of the world, the United States and the USSR, were in a technological one-upmanship game called the space race. To keep up with the USSR after the launch of the Sputnik satellite in 1957, the United States created NASA just a year later, subsequently creating the Apollo missions that the government dumped billions of dollars into. Today, NASA has significantly less funding than it once had. The truth is, the excitement for the space race and space technology waned once we reached the moon. It was over, America won, and everyone at NASA seemed ready to move on and look for ways to save money. To put it into perspective, in today's money, getting somebody to the moon, more or less, costs a colossal $100 billion, which is way too expensive for NASA's $25 billion government stipend. However, just because people are no longer going to the moon doesn't mean we've stopped being curious about it. We've since cut expenses by sending spacecrafts and rovers to do human-free exploration. Spacecrafts are not only cost-efficient, but also safer to use than human life. They don't need food, water, oxygen, or sleep, and they can't really die, can they? Since Apollo 11, space travel has become more and more of a global collaboration rather than a fierce competition between nations. Up until the 90s, all moon missions were dominated by the Americans and the Soviets, but other countries, including Japan, India, and China, have since created their own unique space programs and missions to examine different parts of the moon. China's most recent space mission to the fabled dark side of the moon could potentially fill in a critical gap in history between the moon that was once an ocean of lava and the moon as we see it today. The samples collected from this program possibly confirm molten volcanic activity, further deepening this mystery. All the samples Apollo 11 brought home were thought to be over 3 billion years old. On the other hand, the rocks that China brought back to Earth were younger, carbon dated to be just 2 billion years old, helping to fill a billion-year gap. Some say this discovery of new moon rock samples is the beginning of a new space race. Except this time, the United States isn't in it to play catch-up. Instead, it and many other space stations around the globe want to work together for space exploration that involves not just the wealthiest nations, but all of humanity. NASA has had plans to put people back on the moon for quite some time now, revitalizing the initiative back in 2005, but due to additional cuts in government funding, the mission had to be shelved back in 2011. Thankfully, in 2017, NASA announced the next generation of American moon efforts, known as the Artemis mission. With this mission, NASA plans to send the first man and woman to the moon's south pole by 2025. No one could predict what we're going to find on the moon next, but the next 50 years of space exploration will surely bring new discoveries, better understanding of our closest celestial neighbor, and greater comprehension of the cosmic perfection that is our solar system. What do you think about the current and upcoming journeys to the moon? Do you think we could ever live on it? Let us know down in the comment section below, and if you enjoyed the video, please hit the like button. Don't forget to subscribe to Skies TL if you haven't already, and hit the bell icon to get notified whenever we post new content. Thanks for watching, and we'll see you in the next one.